So what's going on everyone? In this video we'll be seeing how to parse the function addresses from the base address of the DLL. In the previous video we have seen how to retrieve the NT-DLL base address. So in this video we will be parsing the exported function addresses from this base address. So I just opened our 32-bit binary in Win32. So this is the base address. So this is the PE file format, and to reach this export directory, you have this export directory in optional header. Here we will have the information about the exports, we have the function names and the function addresses offsets. So to reach this export directory we need to parse the PE file from starting. So this first 64 bytes, so each row is 16 bytes, so the first 64 bytes are the DOS header, and in the last member of the DOS header, that is the ELFA new, so this is the offset to the NT header. So if you add the base address to this ELFA new offset, you will get a pointer to the starting of the NT header. In the NT header we have three values, three main members, that is the signature, file header and the optional header. So first let's go and add this value. Press 0xF0. You can see 4550. So that is the ASCII for PE. You can see the value PE, and if you add 4 bytes to this, you will get the image file header. So let's parse reference this one. We can see this is the file header. You will see the same contents in PE bar 14C8 FC3ED07C. So we can calculate the size of image file header. So after these 14 hexadecimal bytes, you will have the optional header. So let's also parse that one. Plus 0x14. And here you can see the data directory. It is an array of image data directory structures. So this is of the offset 0x60. So that means you can add the 0x60 and parse this one. You can see 115 2d0 and the export directory is 115 2d0. So we need to add these three values. So let's so 0x78 bytes. So that means after a ELFA new offset, if you add 78 hexadecimal bytes, you will go directly to the export directory. And if you want to go to the import directory, you need to add +8, because each image data directory is 8 bytes. So virtual address is 4 bytes and what size is 8 bytes. So let's go and actually go to the export directory address. So we have NT-DLL address in the variable and the EAX register. And move reading the first 4 bytes from offset 60. So this is the ELFA new offset, and add NTDLL base address. So that's what we have done here. We have read the F0, which is the ELFNU value for the NTDLL, and copying it into EBX. We need to add the DLL base address because this ELFNU is only the offset. Now we need to add 78. So now if you read, now if you we are here, if you read 4 bytes, you will retrieve the export directory offset. EBX plus, sorry, normally EBX. So EBX now contains the offset. We need to add again the NTDLL base address. Now we have reached the exports. So how we are going to parse exports is, we will copy the value of number of names into ECX register, and this is the image export directory. And to reach this number of names, we need to add the sizes of these members: 4, 8, 10, 12, 14, 18, sorry, 4, 8, 10, 12, 16, 20, 24. So if you add 24 bytes from the starting, you will retrieve the number of names. So move ECX comma D word pointer EBX plus 24. ECX is equals to number of names. Now we need to copy the address of names. So this address of names contains the RVS to the names. So if you read first 4 bytes, 11B4A4. If you go to that base address plus 11B4A4, you can see the actual bytes, that is the function name. Now to retrieve the function address, we need to get the offset of this one. So for the first element, the index is 0. So we need to find the index at which this the address resides. So the first function is a sharp final, and the index will be 0. So we will be looping through this array of addresses, and at particular index, say the first element 0 is the index in this array, and we need to read the 0 index at this address of name ordinals. So you need to read 2 bytes. So at 0 index we have the 7 value, and you need to go to the 7th index in this address of functions. So 7th index, so 4, 5, 6, 7. So this might be the 7th index or 8th element. So if you read the 4 bytes, you will have the function RVA. You need to add the NTDLL base address to get the full function address. So let's go and do this. Address of names, let's copy this into the ESI register. So the number of names is 24 and 28 and 32. EBX plus 32. Address of names. So let's clear the EDX. So let's go and loop through these addresses. So we are at this position, address of names. We need to read 4 bytes. So the EDX will be acting as a counter. So in the for loop in the higher level languages, we will be using for I as a iterator. And one thing, we need to add the NTDLL address. So move let's say EDI comma the word pointer at ESI plus the index, that is EDX, into 4. We need to iterate over the 4 elements because we are reading 4 bytes. So in the first iteration we will be reading these 4 bytes, and in the second iteration we will be reading these 4, and third iteration these 4, etc., and so on. So these 4 bytes will be stored in the EDI register, and we need to add the NTDLL address, and we will be getting at this point. And we already seen the compare two strings function. If you did not watch that video, watch my previous videos on writing a function to compare if two strings are equal. Now we have the address of this function name, and we want to find the function address of NT query system information. So src function length. So we are incrementing EDX and decrementing ECX. ECX is the loop counter and EDX is the index of the array. And now we need to push the src function length. So we have written the function. The third argument is length of the string 1, and the second argument is address of string 2. Push EDI value, and the first argument is address of string 1, that is push offset src function, and call compare two strings, and the return value will be stored in the EAX. Compare EAX comma 1. So 1 means we have successful, so that means the address at this EDI have the correct value, NT query system information. So jump if equal to found string. So let's say this as another label, found string. So at this point we have found the string, so all we need is the EDX value. So the EDX is the index, so EDX is the index. So EDX can be 0 for the first one, so EDX can be 0 here, and we need to copy the 0 index at this address of name ordinals. So let's go and do that. So EDX contains index to name ordinals, so we have EBX contains exports address. So we need to find the address of name ordinals. So the address of names is from 24, and if you add +4 you will retrieve the address of name address. Sorry, 32 is address of names. So 36 should be the offset to address of name address. Move dword pointer EBX 36. So let's copy this into ESI. And add the NTDLL address to the ESI register. Now we are at this point. We need to read the index of this EDX. So move copy the dword pointer at ESI plus EDX into 2. So if it's first one, we will have the EDX value as 0. 0 into 2, that is 0. We will be reading the first 2 bytes, 7. Let's copy this into ECX. Sorry, word pointer CX. So CX contains the value 7. Now we need to go to the address of functions and copy the 7th index. And the address of names is at 32 offset address of names, and if you subtract 4 you will have the address of functions, that is 28. So move ESI comma dword pointer EBX plus 28. And add ESI comma NTDLL address. So now you will have at this point we need to read the 7th index. So move dword pointer ESI plus EDX into 4. Sorry, not EDX, that is ECX. So we have copied the value into ECX. Now let's store this as ESI because we have the offset here, and we need to again add the NTDLL address. So now we are good to go. So I think we have got the function. So let's complete this loop. So we have found the string, we are jumping into this found string, and here we are going to jump exiting. ESI contains function address. So after decrementing the ECX, we need to compare if ECX is equals to 0 or not, because we are decreasing from number of functions 9b3 to 0. So instead of like incrementing looping from 100 to 0, we can go from 101 to 1 to avoid that the 0 value, because we will get the null byte. So we are going to increment ECX and compare this ECX to 1. If jump is not is equals to loop 1, sorry, loop 2. So if we did not loop through all the names, number of names, we are going to loop all through these names until we receive the ECX is equals to 1. So now jump, exiting. So now we can say XOR ESI comma ESI to just clear the ESI. So ESI here contains the function address. If we did not find our string, then ESI points to 0. So let's close this and build this. Let's put breakpoint at main function and let's run this. Let's put a breakpoint at which we retrieve the integer base address at this point. So let's run this and we can see EAX contains 76F5000. We can confirm this one. So let's step through the instructions. We are copying the integer base address EAX register into the EBX and we are retrieving the 4 bytes of ELFA new. So remember that 60 offset, and here we can see EBX is F0 and we are adding integer base address. Now we are reading the export directory offset because we have calculated the 78 bytes from the NT header, from the signature field. So let's run this and we are now reading the 1152D0 and adding the integer base address. So this is where we have reached the exports structure. Now we are copying the number of names into ECX. So let's run this. ECX contains 9B3, incrementing ECX, and ESI now should contain the address of names, which is 1179C4. So 1179C4. And adding the integer base address. Now we are going to copy the first 4 bytes 11B494 11B4A4 into the EDA register. So you can see 11B4A4 and we are adding the integer base address to this, and this address contains the name of the function. So we can verify this one. You can see Acer final. Pushing the function length and the address of string 2 and string 1, then comparing, and after the call EAX contains 0. So that means this is not the string we want. We want NT query system information, and since it is not equal, we will be incrementing EDX, decrementing ECX, and comparing if ECX is equals to 1 or not. If it's not equal to 1, then we are again continuing the loop. You can see we came to the starting. Now we are copying this next bytes 11B4AF. So you can see 11B4AF and continuing the same. Now this address contains the pointer to the string of next function Acer init. So Acer init and so on. So this loops continues until all the function names are tested. We can set a breakpoint at this found string. So So compare EAX comma 1, jump if equal to this address. So let's breakpoint this one. So this you can verify here, 901082 XR ECX comma ECX. So this is the first instruction, so that is the correct address. And let's continue, and you can see the EAX contains 1. That means our function successfully found the two strings are equal. So the EDA contains the function address. So DA display ASCII, you can see NT query system information. Now the EDX is the index, so 208. So we need to read the 208 index from 208 index in the address of name ordinals. So NT query so here you can see E10D, E10D. So this is the name RVA. So 217. So here we have the 208 because there are some other functions where we cannot read from the directly reading this address of names. So the PA will fetch some more extra functions. You can see the starting. If you go to this address of names, the first one is 11B4A4 and 11B4A4 is Acer final. So we cannot read this RTL functions, runtime library functions. So let's continue, and now we are copying the name ordinals offset 118090 into ESI 118090 and adding the interior base address and copying the index into the CX register. So 20F so 20F so you can see 20F plus 8, that gives you the 217. So the 217 is the ordinal value here for NT query system information. So that 8 bytes is the first 8 RTL functions that are before the Acer final function we have seen. So now we are copying the 1152F8 and reading, adding the interior base address and reading at the index into 4. So the 20th in element of the array. So ESI contains 76A50. So here you can see the function RVA is 76A50. So that's the same value we have received in the ESI register. So let's add the interior base address. So this is the function address, so DD. So this is the address of the anti-query system information. You can confirm this by reading the bytes. B836 zeros BAF0. So those are the same values. BIF09031. So that's all for this video. So we have seen how to retrieve the function address using the assembly.